Welcome back to our fourth and final week of the Whitesands public inquiry. We have a few new members, witnesses and members of the public who have not been with us before, so I'll just very briefly explain who we are and why we're here. My name is Lorna McCallum. I'm a reporter with the Scottish Planning and Environmental Appeals Division. My colleague is Mr Dan Jackman, who's an Assistant Chief Reporter. And we've been jointly appointed by the Scottish Ministers to consider the objections to the proposed flood protection order for the Whitesands and to prepare a report for the Scottish Minister. Could I just check that everyone has their phones either switched off or on silent, please? And we're not expecting any fire drills today, but if the fire alarm should ring, then it's out these doors and back out the main entrance. And we are being webcast again, so the microphones are essential to the process. Switch them off and switch them on when we're using them. Today is a continuation of the technical matters inquiry session, and we have Mr Vermont as a witness on behalf of Save Our Sands. Tomorrow we have one more inquiry session, and that is to hear Mr White, who's joined us in the audience today. And both afternoons this week we will have our site inspections, and on Thursday morning we will be visiting Nunholm. I'll talk briefly about the site inspections when we finish this morning. Okay, so if everyone's ready to proceed, could I hand over to Mr Vermont? I could hand over, and Mr Dowson, could you introduce your witness, please?
Yes, very briefly, I'd like to introduce Oliver Vermont, who's come. He tells me his hometown is Antwerp, and we are very grateful to him for making such a long journey. I believe he did get some sleep last night, but we're very grateful to him for coming over. I think the best thing is maybe just to hand over to him and let him give his recognition, but if I could say that given the time delay, there probably would be a few questions that I might like to ask in clarification later. Thank you.
Well, my name is Oliver Vermont. First off, I would like to thank everybody for your time and for having me here to hear what I would have to say. I'm an associate director at Ageres Flood Solutions, and before I founded Ageres in 2011 with my brother, I have been self-employed as a construction consultant and active in project development, mainly in Belgium. Ageres was founded under the name Benelux Flood Defence Systems in 2011 after heavy floods in the Flanders region, with the ambition of creating solutions for the private homeowner up to government projects. Ageres currently employs 7 people directly and has strategic partnerships with several companies for design and building the barrier systems. A license for distributing the self-closing flood barrier was initially obtained through a UK-based company. In 2014, the UK company lost its rights to the self-closing flood barrier due to malpractice, and our company obtained the exclusive rights for the barrier in the Benelux region and the non-exclusive worldwide license straight from the patent holder. Ever since, we have been involved in a number of large-scale projects. Next to the self-closing flood barrier, we design and build various systems that are a contribution to the self-closing flood barrier. In 2014, we changed the company name from Benelux Flood Defence Systems to Ageres, which is actually Latin, dikes in Latin. Our company has steadily become the authority for the Benelux market in our field, building for clients such as Rijkswaterstaat, several water boards in Holland, and the main water board in Belgium, which is the Vlaamse Waterweg, and several governmental organizations in Belgium and Holland. Our company has successfully transformed the self-closing flood barrier from an innovative solution to a mainstream usable product for the Dutch primary dike system according to the Dutch government. Ever since our main project, now Spakenburg Poort, was built, we have identified 14 new governmental projects that are more than likely to be built with the self-closing flood barrier. Most of these projects are currently located in the Benelux region. Our company offers a full service from design and build up to maintenance for all of its projects. I've added a list of the projects we've done in the last years, and I won't go over all of them, but 3 projects which are representative are the 1.11 tree in Antwerp. It's not a big barrier. It's a 1.25 meter high, 4 meter wide barrier. But the reason I want to highlight it is because it's safe, it protects an underground parking garage, and it has successfully prevented 4 floodings in the past, for which nobody would have been there in time if it would have been any manual or electrical system, because electricity tends to fail. Then the Eindhoven, the 1.11.4 Eindhoven project was the first rather large project, which is representative. It's a 34 meter long, 1 meter high barrier, but it sits actually underwater in a pond. So the speciality of the self-closing flood barrier is its floating gate. So you would expect it to float up the whole time. And this is a critical point because we were able to install it underwater, which points out the technicity that no dirt will go into the basin, and it is actually practically maintenance-free. And then, as I pointed out before, the 1.11.5 Spakenburg project, which was for Rijkswaterstaat, the Dutch authority on everything water-related, is a 300-meter, 1 meter high barrier, which crosses the historic city of Spakenburg, on which we have done everything from basically the first design up to installation, and which has become even more of a tourist attraction up to now since we've installed it. After we installed the Spakenburg project, a lot of projects all went into study phase. So we currently are identifying a lot of new projects, for which we are a little bit too soon to be able to clarify on which projects these would come. So I've listed vaguely what they will be about, but normally in 3 months' time there will be a lot of new projects which we will be able to elaborate on. If I can go ahead to my personal projects insights, I've seen the current scheme, and as I comprehended from the scheme, is the current embankment of the river will be raised with a green dike and a walkway with glass wall on top. At various locations, apertures will be left in the glass wall to accommodate access to the river park site. These are likely to be closed by a manual demountable system or a hydraulic system, as I've come to hear yesterday. Personal opinions to the proposed schemes is the current proposed scheme seems valid, although I would like to raise some concerns. Is the high risk of failure of the demountable flood defenses foreseen in the apertures. The risk of failure is mainly due to these factors. Catastrophic event in a warehouse where the demountables would be stored, lack of trained staff at the time they would need to have to build up, Then a big issue is the logistical problem between warehouse and build-up site, damage to material during build-up time, unwanted long time apertures are closed, so in a flood event you have to foresee that maybe a few days in advance you could close them off. If there's no need for it, if the flood doesn't happen, they will have closed with no use actually. And the high life cycle cost of the system. So you would have a warehouse rental, training, replacements. And, well, any defense system is but as strong as its weakest link. So still, if you would be able to close 13 of the apertures and leave one open, you still have nothing actually at all. This is also not only my, if I can elaborate on it, not my opinion. Currently in Holland, the water boards, they are stepping away from the demountable systems as they can no longer guarantee it's called the fail-safe analysis. So then to go ahead, the underestimation of the total life cycle cost of the glass wall system is a glass wall is prone to and very attractive to vandalism, graffiti, glass break, and scratching. It might allow some visual open space feeling. The barrier still becomes a physical and visual barrier, preventing an open space feeling. Windows will quickly become less transparent over time than anticipated. Cleaning costs and replacement. The underestimation of the total build costs. Substructures often not taken in account. So possible panic when flood levels reach above fixed wall level and against the glass wall. And then for the green dike, as from the renders, I have the feeling that there is not much space between the houses and the river bank. A lower dike or no dike would vastly enlarge the promenade area, allowing for more space for either leisure or practical space as a car park. Then I would like to give some pros on the self-closing flood barrier, as the current scheme would easily be adapted to facilitate the self-closing flood barrier. Fixed dike level can be lowered in some parts to create a more open space and free access to the water side. Flood defense systems permanently present on site, which is very important, I believe. There would be no human interference for activation or deactivation. Barrier basins acts as a stability in dike and prevents possible piping issues. It's a proven system with a perfect track record. We are very flexible in height levels and sloping surroundings. Possibility to increase the protection height in a later stage. There is a very rapid construction time because of renewed prefab installations. And then a very important point in the life cycle cost is there is practically no maintenance costs or very low maintenance cost to the system. And added tourist benefits as the barrier itself larger and more makes for a larger and more accessible promenade, catering possibilities on the promenade, etc. And as the maintenance costs are that low, as the system has a very low life cycle cost, which I think is the most important fact. System is very flexible in design and can be hidden from sight. The basis it can be a basis for a bench or a basis for a small retaining wall. The total required retaining height can be achieved with the self-closing flood barrier. These either flush with the ground level or hidden in a low wall that can be used as a bench or a step. The underground precast concrete basins serves as a double function. It is the foundation for the floating wall and serves as a watertight underground screen. Then to go to engineering, construction and pricing. The system is no longer a prototype innovative system, but an engineered certified product which is in production for most required heights. With some adaptations, the barrier can be raised, higher level of protection post-installation if required. Ageres is experienced to work closely together with the prescribed engineering agencies to implement the system in the current scheme. We are convinced that this can be done in a very short period of time. The floating barrier sections are produced in an experienced European factory, preserving a high standard in elements. The substructure, precast concrete basins and steel parts would more likely to be built by locally anchored contractors, for whom Ageres would deliver drawings and molds and would supervise the construction. The construction itself is always outsourced to local contractors, as we have done with our projects in Holland. This under close supervision and guidance of experienced representatives of Ageres. Then an estimation, but we are convinced that an installation of about 450 meters, similar to Spakenburg, can be done within a period of 8 to 12 months. This would include furnishing the surrounding area. To go to the conclusion, we would suggest to do a short feasibility study to determine if the self-closing flood barrier is a valuable alternative. First indications from our experience show that this project suits perfectly for the self-closing flood barrier, and the self-closing flood barrier would create a more attractive and functional riverbank area. It can offer a higher reliability than the current scheme and a budget which I've heard of in the media. I don't know which would be included or not, but I think of 25 million euros can be greatly reduced even with all accommodations. That is, I think, yeah. Thank you for your time.
Thank you, Mr. Vermont. Mr. Dyson.
Yes, thank you. I wanted to just refer to one document that we submitted, which is SOS 059. Mr. Vermont, this is the document you've produced, which showed us the three schemes with 53 slides. Just merely to say that we were a bit disappointed we weren't able to show some of the illustrations of that, but we do want to make sure that, and I'm sure the reporters will look at your document, they look at every document, so that is good. I'm also aware that Mr. Vermont has brought with him another document. Now, it's not been submitted, so he hasn't distributed it. So we're seeking guidance on that from you.
Okay. Firstly, could you tell us what it is, and then I'll seek comments from Mr. Connell.
Mr. Vermont, could you tell us what your document?
This is merely a brochure with several, mostly pictures of the projects we've done up to now, and some explaining of what because I've actually noticed that I've not really described the functionality and how the system works. I don't know if it's clear to everybody what the operational function of the barrier is, but it's more described because a visual representation would clarify more than words, I believe, what can be done with the system.
Mr. Connell, do you have any objections to that document being lodged?
No, ma'am. Obviously, I haven't seen it, but as it's essentially a brochure for Mr. Femont's company, I don't think I can object to it coming in for what it's worth.
Okay, that's fine. Thanks very much. Mr. Dyson, is it only available in paper copy, or is there an electronic version of this?
No, we can. I haven't taken the digital version, but I can send it in a digital version as well.
Okay, we're quite happy for the paper copies to be distributed to the parties, but if we could also have the electronic copy forwarded to the case officer, Mr. Mackenzie. Mr. Dowson, could you do that?
Yes, I'll do that, yes, certainly. Thank you.
Do you have any further points at this stage?
Yeah. I just wanted to go over a few points that have come out in previous evidence that's come under the technical section, and maybe ask Mr. Femont to just explain a little bit more. One of the issues is that this is seen as fairly new technology, but you've said in here that it's now, in your opinion, tried and tested. You mentioned various governments, so like the Dutch government particularly. Could you tell us a little bit more about the certificates or the approval of that?
Well, the Dutch primary dike system is the main dike system and the most important dike system that protects Holland, which is for 60% under the water level. And for any system to be able to be used within the primary dike system, it has to, I'm looking for words, to be certified that it will operate when it needs to operate. So they calculate a chance of failure of the system, and they do it even for green dikes and concrete walls. Is the chance of failure in operation, and they have concluded that this system currently, because of the independence of human interference or electricity, or just we use the laws of physics, is the safest system that can be installed, where there is no space for a concrete wall or a green dike. That will mainly in Holland will always take the overhand, but once there is a request to have a visual contact with a river, or to not have a physical barrier, this can be installed now within the Dutch primary dike system. We have done a lot of studies. They're all in Dutch. I would be happy to send them, but it would be a lot of translating, I suppose. So,
You mentioned maintenance. Could you tell us a little bit more about the maintenance of your system? And I mean by maintenance, short term, what you would have to do annually every year, and maybe longer term as well.
Well, in fact, once installed, the barrier, it is a composite element. So you would have the floating wall itself is made up out of composite elements, and they have a lid. And when not in use, the whole system hangs in a dark concrete basin from its lid. So actually, there is no sunlight. It's a dry chamber, and there is hardly anything that can penetrate the basin. So the system remains statically when not in use. It can hardly be tampered with. So with our projects now we've done on a yearly basis, we just shut the outlets towards the river you can manually shut them, close them off, and then fill up the system with water, which can be done by one person in half a day's time. And that would make the barriers to rise up all by themselves. We would just need a pump and one person. And they can be visually inspected on a yearly basis to see if there is any problem with mainly the rubber seals. And then when the visual inspection has been done, you can open the valves and let the water out, which would flush the basins with the water would flush out and take most of the debris out. When needed and when there is a presumption that there might be some dirt in the basins, it would be fairly easy to have a camera inspection to look into the basins under the walls. And then on a return period of 20 years, we would expect to have to take the wall systems out to have a more thorough inspections of the seals to see what the deterioration of the rubber seals would be, and to have a echographic inspection of the composite walls to see if there would be any decomposition, which is not expected, as we guarantee a life cycle, it should have a lifetime of 50 years, actually. The floating walls, yeah, I was looking for the words. And then on everything which is installed firmly into the ground, so the concrete basins, they should have a life cycle of 100 years. So mainly you would have a yearly basic inspection. You would have a 20-year return period on taking the walls out and have a more thorough inspection. Then on the 50th year or longer, if needed, there might be a replacement of some sections of the wall. That would be, we would have to examine if that would be needed. And well, yeah, that is mostly the main part of the work.
We heard earlier from UK systems that needed vertical supports sort of every 10 or 15 metres. I understand your Spakenburg scheme is longer. Could you tell us about vertical supports? I think you mentioned something like 30 metres to me. Could you tell us about that?
Well, actually the wall system doesn't need any vertical supports. At the ends of the wall, you would need a vertical seal to have your watertight connections to the fixed structure on which the barrier ends. But the wall in itself, once it comes up, it hinges, or it forces itself within a wedge, and it cannot be turned over by the water force. So we don't actually need the vertical intermediate posts. In Spakenburg, however, we have used every 30 meters, more or less, there is a small post on which we end the section. This is more for practical reasons, because there is a length of 160 meters. If in the 20-year return period we would need to take out the total 120 meters, this would be much more work than when we can take out the 30-meter wall in one piece, but the 160-meter wall would be more difficult to do. And
sorry, the word vertical supports, does that apply irrespective of the height?
The height of the wall doesn't have any many people think that we need the vertical supports for the wall to push and to have the forces, but the forces actually are transmitted. You have the composite element, which it's stuck at the bottom, so all the forces from the water are transmitted directly into the foundations at the bottom and will not be transmitted at the ends of the barrier. And this is generally a misconception that it needs to transmit the forces to the posts. In fact, we are now working on a project which has 2 times 175 meters on either side of a lock, and on the surface there cannot be any posts at all. So we're working now on a system that first the posts would come out of the ground and then the barrier systems would rise in between of them. This is mainly because we have a difference in height. So we have a 2 meter high barrier which ends up into nothing. So we need to gradually make lower barriers, and in between the high and the lower barriers there are posts, and these could not be visual, so they need to be so these will be self-closing poles, and then this will be a beautiful system. But we can elaborate on it probably in January.
One other worry that people have is maybe vandalism or damage being done. Could you comment on that? You mentioned in your statement that you felt quite secure about that. Are you happy about that?
Well, this is why I usually take one of our cases is the Van Abbe Museum. We've been able to install the barrier under about 30 centimeters of water, and there is we have some seepage, which is minimal at the ends of the barrier, and the pump needs to evacuate about 100 liters every 2 weeks. So there is hardly any seepage of water. And this actually means that the barrier closes off from its lid when it's not in activation, that it sits flush on the ground, and you cannot tamper with it. It's very difficult to manually take it out. Some of the vandalism that you could expect is the in and outlets towards the river, which can be easily inspected visually in certain return periods. If there is any blockage, people would put a paper bag in it. But that would be solved on putting in more redundant in and out. You would never expect a barrier for 450 meters to just activate on one in and outlet. You would probably have a dozen in and outlets. And if you have, for instance, 10 in and out pits that would activate the barrier in total, and on every pit you would have 2 in a high and a low in and outlet. They can all be blocked, and if only one would be open, that will fill up the whole system and still activate. So you have so many redundancies on the barrier that it would be very difficult not to have it rise up. And some things you should avoid is to have to make it possible that there is a car park, the cars park on top of it. That we've solved in Spakenburg, because there it's possible that cars would park on top of it, is that the water board has the possibility to open the system sooner than at a critical level. So they would do an inspection round, and if the barrier is free, they just open manually a valve, and then the barrier comes up sooner than it needs to come up. But if nobody would be able to come to the site, it will eventually come up anyway. So there is so many fail-safe mechanisms that you can implement that. That's the reason actually that they in Holland are very enthusiastic about the system.
I was able to take you down to the Whitesands last night. It was a bit dark, but I particularly wanted your comments on the Devergilla Bridge, the old bridge. Do you think your system can be there with minimal or no interventions on the bridge? Could you comment on that?
Well, I would need to. This would be a subject of further investigation and how we could, because I can already think of 2 or 3 ways to work around the bridge and to make sure it isn't affected. It can be with a minimal visual impact. We can go around. There are several ways of making sure that the visual or the bridge stays as it is.
I was quite interested, you mentioned, I think, that it's become a tourist attraction in Spakenburg. Could you tell us a little bit more about that? Are people seeing this as the future of flood protection work, not just in Benelux and in Holland and Belgium, but perhaps throughout the world? I know you've been to other countries, but could you tell us a bit about the tourist attraction?
Well, the city of Spakenburg was a touristic city from the beginning, and one of the reasons that they wanted to have their city center, they didn't want any walls within the city center. In our first proposed scheme, we made sure that only the top lid of the barrier would be visual, and it was produced in Corten steel, so it has a rusty look, and it's supposed to look rusty. And we've proposed to the government to engrave the lid for the 300 meters, to engrave the lid with the local poem of the city. So now, when they have tourists, they can walk around the city and read the local poem through this thin line that travels through the city. Next to that, as it is the first big project and for Rijkswaterstaat in Holland, and it still has the label of an innovative system. The Dutch government does a lot of exports, a lot of technology abroad in water technology. They have the biggest engineering companies and so forth. So they have a lot of delegations that visit the site these days. And recently we have had the opportunity to the Royal King of Holland, Willem-Alexander, came to see the project himself, because there were that many rumors about it that he wanted to see it for himself, as his water protection is some of his personal interests. So there's been quite a more turnover on extra tourists in the region. Yeah.
Thank you. I think that's most of the supplementary questions I wanted to ask. Okay.
Mr. Connell, do you have any questions?
Thank you, ma'am. Mr. Freeman, we've already heard from Mr. Marchand of M3 Flood Tech, who is a UK holder of rights to a similar system. So that will avoid me asking you all of the questions I need to. I maybe have some where you differ from what he says. Can you just tell me, as a matter of information, in paragraph 1.5 of your recognition, if you've got it there, you say that you got your rights after a UK company lost their rights. What was that? Which company was the one that lost its rights?
It was UK flood barriers at that time.
Thank you. Now, in terms of the steps you've taken before coming here in order to allow you to give evidence to this inquiry, what have you had a chance to look at apart from your visit to the site last night?
Basically, at this time, I've seen there was this virtual 3D render video of the scheme. I've read about it, but it was I didn't look into the detailed plans, as I've not seen them yet, and what I've heard of of John, what it's currently about. So there's mainly the video gave me a good impression of what was proposed.
Thank you. Now, I'll come to some of your comments on the existing proposal in a minute. But just thinking about the system that you're looking to sell to customers, you accepted a minute or two ago that it's still treated, at least by the Dutch government, as an innovative scheme.
Well, before the installation of Spakenburg, it had a stamp of innovative. Now, how can you any time you would want to protect with composite elements, this would be innovative. Now, in Belgium and Holland, we are more and more using composite bridges. They're finding their way. These were innovative still. They use them now and into transport. And we have to ask ourselves that can we go forward in using new technology on every domain, or are we going to sit still and let every domain go more technically advanced, and we sit still at this domain? I believe the innovative stamp will still sit on it because it's composite, although it can be used, it can be prescribed by any Dutch water board directly in their tenders to be used in their dike systems. So it's on the one hand you have the innovative stamp on it. On the other hand, it can now be prescribed directly off the books within any dike in Holland.
And as far as current schemes are concerned, and you've explained to us that you're working on a number of projects, the details of which you can't really give us at the moment for perfectly understandable reasons, but at the moment, all the schemes that you've illustrated in your statement, in your, what we call a precognition for reasons that we don't know why we use that odd word, it doesn't really matter. Anyway, that's what we call it here. What you've illustrated there, they're all either for relatively short lengths, perhaps for the reason you illustrated about where you might have needed a power source and you worried that the power would go out, or in one case at Spakenburg, a longer system but a relatively low height at 1 meter. Is that correct?
Currently, that's correct, and I believe we've worked hard on getting it known, and the Spakenburg project was a first step of the government in accepting the system and the operational system, and we've wished that governments in Belgium and Holland would go a little bit faster from time to time, but still, as I believe this is not an exception to any project, but after Spakenburg, the whole of Holland, the water world in Holland has been looking towards the project in Spakenburg and what it has delivered of being, and is this product viable. And they've stopped actually some projects, and redone the study to see if they can be redone with the self-closing flood barrier. And this we've worked for the Spakenburg project, for instance. We've known for it for 5.5 years before we started installing it. The study time was 3 years into making a sound plan at the beginning, because the government needed to do a special tender request for us to be able to implement it. And then the actual build time was 6 months. And we overhauled the whole town. We rebuilt roads. We strengthened K-walls. So we've done a lot in just 6 months. And I think now the projects are coming faster and faster. I wished this interview would have been in by the end of January or February. We could have not told you more about installed projects, but I could have shown perhaps more plans of what we are going to do, because they're quite ingenious. But the height of the barrier is actually no effect. We've done 2-meter high barriers in shorter lengths, but they operate exactly in the same way, so there are no issue.
So at the moment, we're agreed, I think, that there are no 3-meter high barriers currently installed. I think, in fairness to you, in the material you've produced for this inquiry, you've indicated one of the issues with a 3-meter high barrier is you have to create an up to 4.5 meter deep container pit, whatever you want to call it, in order to install a barrier of that size. Is that correct?
That would be more or less correct, yes. Whether or not you want it flush with the ground, but actually, as I told in the precognition, is that it serves a double function. So you would have a watertight screen underground to avoid piping when you have a high water situation and you would have a sandy, or you would have a pebble underground. You would have a high risk of piping, which means that the water would go under the barrier, and you would need a watertight screen to avoid this. And it's very important to indicate that the basins itself serves as that function. And I believe that in any case you would need this watertight screen even with another system you would implement. So I think it's a double win, actually.
So if you're concerned about piping, which I think we've called seepage, in other words, water coming underneath the surface level, then you would be able to deal with that by a concrete barrier, for instance, underground, as planned in this case.
Well, I don't know the exact geological build-up of the underground yet. I haven't seen the documents in that respect. It can be done with concrete. That would be, if you would just, it can be done with, how it's called, these steel that they hammer in. No, steel pilings or these well, I don't know the English word for them. They're steel walls. They used to build up K-walls as well with them. There are a number of ways for dealing with them, but it can be done with a concrete wall as well, yeah.
Now, we heard from Mr. Marchant of M3 Flood Tech that you did need posts for a self-rising barrier system. So you think he's wrong about that, do you?
I would not know. You wouldn't need them for the barriers itself. It would be more practical, and you can aesthetically integrate them in the landscape. For instance, I've seen now in the current location there are lantern posts. You could easily adapt the lantern post to be at sections of 30 meters, and that 2 sections of barrier would just close off on the lantern post. That would be one of the possibilities. If we would want to go the 450 meters in one stretch, that would be possible if we go rather straight and make curves within certain angles. But this would all be, I think, a matter of, I would have to do a more thorough study of what's the need and what the current scheme looks like on paper to be able to give more insight into it.
When you were asked about maintenance, you accepted that one of the issues that you have to look out for is debris or perhaps silt or anything else entering into the chambers and pipework of the system. That's a recognised issue you have to deal with.
Well, under normal circumstances, the basin, so as long as it hasn't been activated, you can expect it to be dry, because if there is any water in it, the wall will come up, and that will be a visual notification that the wall is up. But on the end, the wall hangs on its lid and is sealed off by a rubber gasket. So there is no sand, and well, we are able to install it underwater, so there won't be any sand or debris being able to come into the basin itself. So the only time you would expect that there would be sand or mud into the basins is after a flood event, a flood. And if it's on a very large scale and a lot of mud and sand, the thing would be that the barrier would not set completely back into its basin. It would, but then you would need really 30 to 40 centimeters of dirt under the barrier. A little bit of dirt wouldn't hurt it, but it's fairly easy to have it maintained, as you would fill the system back up with clean water. And then flush it all out, and it's not so much of a problem to have a little bit of dirt in the basin.
Did you not agree that debris and dirt was something that you had to deal with by maintenance?
That would be, there might be some, well, we've seen spiders, and we've seen, in maintenance cases, usually spiders and that sort of thing. Even though when you fill it up with clean water, there might be some residue left behind. But we haven't had any case yet that there was. It's more because it's prescribed by the water board that we flush the system than because of actual dirt into the system. We have one barrier which is activated out of the sewer system, and there we do a complete maintenance, and we flush it, and we have to sanitize the system, because the system, well, once the sewer system overflows, it fills up the system, and it prevents it from going further. But there are diapers, and there's all sorts of things, and on that particular barrier we need an extra maintenance to make sure that the diapers don't clog up the pumps and all sorts of things. So. And according to your correct assessment, a system is only as strong as its weakest link. So if part of the system doesn't rise correctly, there is, as you put it, no system at all. that would be exact, but we haven't had a single failure up to today. We've tested this Sparkenburg with on several points, trying to block it and so forth. The nicest thing is we use laws of physics, and unless all the boats start to sink suddenly, the system will float up. And for it not to float up, to be blocked, there would be a car on top of it or something that you can easily take off. But in any way, if you have a manual system, you would do an inspection round before you would more or less the principle would be that you would have when a flooding event is imminent, you would have someone to do a basic inspection to make sure that the barriers are clear, that there's nothing sitting on top of it. That's something you would have to do in any case with any system. But if nobody would be able to come on site, they would still work.
And then after the barrier has risen, it's dependent on the falling of the water level to take it back to ground. So if the river, for instance, stayed high but not flooding, then the barrier would stay up in part at that point. Is that correct?
Well, we prefer to use the natural ways to activate and deactivate the barrier. In some cases, like the barrier we installed in for the underground parking garage, there is a pump to evacuate the barrier, to lower the barrier, because the sewer system is higher than the lowest point of the barrier, so you cannot, the water doesn't flow upwards. So if there is a need and there is an expecting that the water would not recede under the bottom level of the basin, it would be advised to use a pumping mechanism to empty the basins, but always to empty the basins, never to activate. That should never be electrified or should never be tampered with, because this is the main part why this barrier scores this well on all the papers on which the fail mechanisms. But to lower after a flood, it might be needed if you want it to lower faster, or the bottom level, the lowest level of the river would never go under the bottom level of the basins, then you would need to evacuate the levels. Yeah.
So if you had a 4.5 meter deep basin here, which was below the level of the river, you'd probably need some form of pumping system to evacuate, to use your term, the basins after the system is activated.
I would not know the exact levels, but I presume that after a flood event, then you might want to deactivate the barrier or pump it out. But that's always after the flood event. Yeah.
You've, in what you describe as your personal project insight, you've made some criticisms of the proposal that this inquiry is considering. Now, you've told us the basis on which you've gathered information to make these criticisms. Can I just put one general point to you? You said, I think in answer to a question from Mr. Dowson, that the system was sometimes used where there wasn't a space for a green dike. Did I pick you up correctly in saying that?
That this system is used when there is not space, not so much space, more when you would like to not have the visual impact of a barrier, and you would want to have a connection towards the river. That would be also the footprint of the barrier is much smaller than a green dike. I think more importantly, if we protect within city centers, is that we don't cut off the city from its past lifeline and from something which is charming to the city. And that is mainly our first objective. And most of the projects we do is because people don't want to be cut off from the river.
It's fair to say that dikes, just call them dikes because that's the word usually used in Holland, are and have been used successfully as flood defences for hundreds of years. That's correct, isn't it?
Well, they've broken, of course, in the past everything. There was a large flood in '53 because of the dikes they broke in Holland. Several thousands of people were killed. So nothing can, even green dikes cannot give you the feel, well, 100% sure. Nevertheless, it's a sound, and I will not say that green dikes are not helpful in where there is space, and in Holland they're widening every time they need to heighten the dike 1 meter. It broadens 5 meters. So I think where there is space and you have an open landscape, there is no issue to use dikes. Although within this scheme, you will either be on the city side and look at the green dike, or you will be on the water side and look at the green dike from the other side. But you will on either part, I think you might have the feeling you'll be on either side of the system, and I think it loses the connection in between and the open space feeling for in between the river and the city.
In your recognition, you set out in section 2 a number of what you described as concerns, particularly in 2.2. These were based, I think, Mr. Fremont, on your understanding that there were going to be gaps in the system which were going to be filled by demountables, by which we mean something stored somewhere else and then brought onto site when there's a flood warning. And in fact, you now know, I think, that that's not a correct understanding. There are no gaps in the general system to be filled by demountables.
Well, I've learned yesterday. I should have perhaps investigated these gaps or these apertures better. That there would be hydraulically lifted barriers. Again, these would I would strongly advise against them because they're still, although their installation might be investment-wise be a sound solution. In our experience, is that they have a very high maintenance cost. There are there is a bigger risk of failure, and I believe, I would, in my opinion, advise against it. So.
And the demountables that you're criticising in your recognition, you probably now know, are only to be installed on top of the glass barriers for the very highest flood events, which there's some debate about it precisely, but we probably haven't seen one here for a very long time. So you now know that's the correct position.
Yes, but still, it keeps my point more or less sound. Is that I'm although our company also sells demountables mainly private households, people who want to close off their garage or their home. I would, in government projects where you have to appoint several people to be able to close them, to know the system, to maintain the system, and to be able, I would, in governmental projects, never advise for demountables in the future.
I have nothing further, ma'am.
Thanks. I do have one or two questions. Can you tell us how easy it might be to adapt a barrier once it's installed if you wanted to increase the height at a later date?
Well, there are actually two options. First, you could foresee a heightening of the barrier system already at installation time, in which we would install a deeper concrete basin, but with a wall system which isn't that high. It would just hang a little bit more from the bottom. And then after, when you would expect to have to heighten the system after 50 years, you would replace the system with higher wall levels. Another solution is that we would heighten just slightly for instance, if we would want to extend the height of the barrier with 50 centimeters, you could extend the ground level by 25 and put 25 more into the wall height. In any way, there are many ways in which we don't have to touch the concrete basin, which is the most important, because that would be the most costly operation to have to change after installation. So you wouldn't want to touch that. And the demountables, we would be able to change them. So I can draw up some ideas on how you would be able to do it. Yeah.
And is there a significant difference or increase in costs as the height of a barrier increases?
Well, mainly it doesn't go up exponentially. It's more of a linear cost rise. Installation-wise, of course, we would have to go deeper into the ground. Usually on our the project we are working on in Holland, it's actually a gain, because they don't have to use the watertight screens, which are also costly. So it's not that much of a problem. But I would be more than happy to have the opportunity to look into the plans more in detail and come up with an estimate which is exact to what the system would cost if it would be implemented. And as for instance the Spakenburg project, we've budgeted it 2 or 3 years in advance, and we actually made some cost benefits for and we build it under the price of our estimate. So once we come out with a price, we are fairly sure that unless the government would like to change things, that we can stick to the price, and it would be the price itself, like at the end of the road.
One of the council's witnesses had mentioned that there's quite a heavy advance costs in investing in a project like this. Is that the case? You briefly touched on sort of payment methods in your precognition, but is there generally a hefty payment in advance to secure the production of the scheme?
Well, the way the wall types, the floating barriers are built, it's a composite element. And actually, it's a glass fiber skin, polyurethane core. It can be depending on the situation of the river, and there can be laminated other skin types within. Then everything is closed within a mold, and there is the process is called vacuum extrusion. So a resin is pulled through the whole mold, so that the glass fiber and the polyurethane become as one composite block. And this process, we can only build one block, 1 meter per day within one mold. So, for instance, for a project being, I would go for the 450 meters, which we are talking, which I've heard about. That would take 450 working days for one mold to produce all the elements. So that gives us a very long lead time on which we would have to start with the project. But for the Spakenburg project, it was granted to us 5.5 months before we should start. So we invested quite heavily in new molds, and we had 5 molds, so we could build 5 meters a day, and we were ready in time to make all the installations. And depending on the project and the short projects, also other projects we have to take in account. But the production process is mainly because it's all precast, it's all done in advance. Once we come on site, the installation goes very rapidly. And so there would be an investment before installation. This can either be, there are several ways of investing, or we have several banks who are behind us who can make sure that we get, if we have the contract, we get payments beforehand. There is not really an issue on this.
Okay, thank you. Some of the previous witnesses have discussed whether or not the underground services that they have at Whitesands can be incorporated into the self-rising barrier system. Is there any possible technical problems in accommodating underground, like sewage and water pipes that need to get to the river across the route of the barrier?
Well, I would that would be under. I would need to investigate how many and their locations. Is if they cross the barrier itself, you would have to cut the barrier into 2 sections and have on top one of the guideposts, as we call it, to accommodate the pipe that goes under it. I think this can be done quite aesthetically, or if they are low in, I wouldn't know the exact position, how many there are. So that would be, I would suggest that would be more under study and to see what we can come up with. It can add to value also. We've seen that there is for instance, an accommodation of public toilets. You would be able to put a new building on top that accommodates, and where the pipe goes and the wall sections would connect to a new building. There are several ways into accommodating this problem.
Thank you. one final question. I think most of my questions have already been asked and answered. But, do you have any experience of the use of, or you mentioned your company uses the demountable barriers, and you've made some criticisms of the council's scheme. Do you have any experience of use of the glass panel flood protection schemes that have been proposed here?
Well, we've been asked this question as well in Holland, and personally, I'm not a fan of it. It's if they're not too high up, it might be okay. But these are they're very heavy on maintenance. They might look very nice in the beginning, but they tend to deteriorate very rapidly, obstructing the clear view. You would always have, if the sun runs through the glass, you would have the light bounces off in different ways. It's actually, it still is physical, but a visual barrier. And if you want to use glass to have this open feeling, I think that will not really make the case. And we are strongly for the self-closing flood barrier. And, well, glass just doesn't give the same feeling. So I think we cannot do both, although we've been asked to provide for the glass walls as well. So, but we're not a fan of it, so we'd like to stick with the self-closing flood barrier.
Okay, thank you. Mr. Dyson, do you have any final points?
You mentioned just a few questions ago about the demountables. I think partly in your statement you diverged a little bit to talk about, you said some of the governments were moving away from demountables and actually now wanting to do studies on replacing. These might be new schemes that are being considered where they were thinking of putting demountables, but now they're wanting you to do studies on rising walls. Did I pick that up correctly? Yeah.
Well, not only are there projects that have been drawn up with demountables, not yet installed, and they're now changing it to the self-closing flood barrier, but there are actually projects that have been built with demountables that they want to change, that they already have invested in demountables, and they want to change to the self-closing flood barrier, because they've seen, for instance, there is one project in Holland. They have 6 kilometers of demountables, 1.5 meters high, and the government not advises, but they have to check annually the whole barrier, so they have to test it to build the 6 kilometer long demountable wall every year. But that's the government who forces them to do so. But the water boards, they just don't have the time nor the resources to annually try and test the whole system. So they do it 1/3 every year. So after 3 years, they've tested the whole system. But now they know that in a flood event, there is, on that particular river, there is a flood warning of about 48 hours. They will need the National Guard. They would need the military to come in and to help build the wall, because there is always an underestimation of how long it takes to build all the walls. For sure, someone drops one aluminum beam, which breaks, which doesn't fit anymore. There is a stress level that goes up because they need to find the right replacement. They have to drive back. There are so many factors that can go wrong with the demountables that on larger schemes that in Holland they just don't go through the fail chance analysis. So they actually on larger scale projects they cannot be used anymore So that's more or less the answer.
Well, I think that's all the questions I have for Oliver. Just to thank you, Oliver, for coming. Thank you.
My pleasure.
I thank Mr. Fremont for his time today. This is going to be the end of our session this morning. We're going to be having an inspection of the site this afternoon. Thankfully, the weather is fine, and the intention is for us to meet at the Whitesands car park at 12:30 today. As discussed, I think there's going to be just one or two parties representing each of the council and Save Sands, and we had made we had been requested by Ms MacDonald and Mr Miller that they wish to join us. The site inspection is really just to allow the reporters to become acquainted with the site, to familiarise themselves with where the scheme is going to go. And there's absolutely no discussion, just in case there is any parties perhaps watching in the webcast, that there is no discussion takes place on site at all of the merits or otherwise of the case. So it is simply just us walking up and down the route to look at the site and making stops at the points that have been listed on the itinerary. So if no one else has any matters to raise at this point in time, what we'll do is we'll confirm tomorrow morning whether or not we're able to keep the papers, etc., in this room until we reconvene later in the week. And I'll get back to that point tomorrow morning. But otherwise, we'll see you at Whitesands at 12:30. Thank you, everybody.